Hello and welcome. In today's session, we will talk about stats or statistics. Now, from a point of view of the test, stats are not really the most important. However, you do get some questions sometimes on variations or standard deviations. They will, of course, give you the complete formula and then ask you a question based on that. So it's just better to be prepared a little bit. And there are other elements of stats like mean, mode, median that appear more regularly. So we'll start with some definitions and then go on to see how you may solve stats problems, the typical problems that you get in your test. So stats is a branch of applied mathematics that deals with collection of data and extracting information. We won't go into too deep into any of these definitions. We will simply focus on the ones that are important from a test perspective. So the universe is basically defined in a wider sense as any collection of objects taken for a statistical inquiry. Each observation is called an individual. We don't really need to know why, but that's just how statistics deals with it. Variate is essentially a variable. A typical equation variable in stats language is called a variate. Attribute is something which is qualitative and not a number. That's called an attribute, as you can see here on the screen. So to illustrate the difference between variate and attribute, let's consider the citizens of United States are classified according to these four parameters: state, religion, sex, and family income. Then the population is formed by the citizens of USA, the attributes of which are state, religion, and sex, whereas family income is a variate, because for family income you can put a quantity like $100,000, $120,000, so that's a number that can denote this, whereas state, there's no number, it's just one of the United States. So and same with religion and sex. Then you have the concept of discrete and continuous variables. A discrete variable could be, for example, a set of odd integers between 1 and 10, and continuous variable could be a set of real numbers between 1 to 10. Sample space is essentially a set of observations drawn from the population in order to study its characteristics. So for example, again going back to a set of integers from 1 to 10, a sample might be 3, 7, 8. So a small portion of the total population. Frequency is essentially the number of times that a particular value occurs in a sample space. So these are some of the definitions that are used in statistics. It's good to be familiar with these definitions, though these are hardly likely to be used in your real test. Okay, next we go to the measures of central tendency. Essentially, it's a tendency for a set of data to cluster around the center of the distribution. The three most important measures that we'll need for the test is arithmetic mean, median, and mode. These three clubbed with variation and standard deviation is pretty much all you need to know from statistics for the test. So let's take the first one of these. Arithmetic mean is essentially the mean or the average. The arithmetic mean of n values of a variable x is denoted by x and a line on the top like this, and is given by the formula. You simply add all the values here and then divide by the number of observations, and in mathematical notation it is given by this sigma. This essentially is a sum of xi, where I equals 1 to n. Essentially what this thing translates into is this. So x is 1 to n, so 1 2 all the way till n, and divided by the total number. So let's have a quick look at a simple example to consolidate our concept of the mean. So the mean of the following set of values is 3. Find the value of a here. So what you do is using our formula, or it's quite commonsensical. So the mean is 3, x bar is 3, and you simply add all the values given here including a and divided by the total number of values, which as you'll count is 12, and you get a simple equation, and thus the value of a is 1. The next important concept is the median. Median is essentially the central value of a set of observations. So if you had for example numbers 1, 2 and 3, the median would be number 2. It's as simple as that. So here are some rules. If the number of observations n is odd, then the median is n plus 1 by 2. So in this example you have 3 observations, the median is 3 plus 1, 4 by 2 is 2, the second observation, which is number 2 here. However, things get more interesting if the number of observations is even. So if you had 1, 2, 3 and 4, then the median is basically the average of 2 and 3, which is 2.5 here. So average of 2 and 3, and this formula is what explains it. So we have 1, 2, 3 and 4 terms. Second term plus 4 plus 1, 5 by 2 plus 1, so third term, and the average of that. So let's try to find the median of a more complex set of numbers. Find the medians of numbers 15, 10, 17, so on till 92. Now to find the median, the first thing we need to do is arrange the numbers in ascending orders and then find the middle number. So what we see is that the number of observations is 8. There are 8 values here, 1, 2, 3, 4, 5, 6, 7, 8. Hence the median is going to be the average or the mean of the 4th and 5th value. Fourth and 5th term divided by 2, and the median comes out to be 27. Quite a simple in terms of concept, but you need to be aware of the definition so that you don't get stuck in a difficult problem situation. The last one is mode. Mode is merely the set of observation that occurs with the greatest frequency. Remember the definition of frequency that we discussed is basically the number of times that a specific value or observation, as is called here, occurs. So for example, if you had a set of observations 2, 2, 5, 7, 9, 9 and so on, what is the mode? All you need to do is to find the value that occurs with the maximum frequency, maximum number of times, and you can easily see that that value is 9, hence the mode is 9. Now what happens if more than one value occurs the same frequency. So if we had another 10 in this scenario, the mode would be 9 and 10, and this distribution would be called multimodal or bimodal in case of just two values. So 9 and 10 would be bimodal. In case you had, for example, 7 occurring 3 times as well, you would call it multimodal. So for example, in this set of observations here, you have two numbers 9 and 10 appearing with the same frequency, and hence this observation is bimodal. So let's look at a quick example to consolidate our understanding. Find the median and mode of the following two observations. So let's start with the first one. Here we can clearly see that the mode would be number 8, since this appears 3 times, and the median, to find the median we have to arrange this in an order, in an ascending order. So done that here, and we find that the number of terms is odd, hence the median would be the middle term, the 5th term, which is number 6. Now looking at the second set of data, we do the same as before. We arrange it in ascending order here, and then we find that the mode is 95, since this is the only number that appears with a frequency of 3, repeats 3 times. And now to find the median, we calculate the number of terms, which are 12, and so the median would be the average of the two middle terms, which is the 6th and the 7th term, and hence the median is 89 as shown here. The next concept is that of standard deviation. So standard deviation essentially measures the deviation around the mean for a set of observations. So let us quickly look at an example to see what exactly do we mean by standard deviation. Assuming you have a set of numbers 1, 2, 3, 4 and 5. Now the mean is number 3, and assuming you have another set of numbers, that would be -1, -2, 3, 4 and 5 and 9. So the mean of both is 3, but as you can see, the deviation in terms of the values which are different from the mean 3 for each of the members is much wider here than here. So that roughly is standard deviation in very simplistic term. This is the formula and this is the symbol for standard deviation, and once we solve a few problems in the session, it'll be more clear. The variance is simply the square of standard deviation. So the symbol for standard deviation squared is variation. Again, when we look at a few more problems subsequently, it'll be clear as to where do we use variation and standard deviation in statistics. But before we do that, here are a few more terms in statistics that are useful to know for the test. So consider 3 sets of data. Set 1 is all the values being the same 50, set 2 being starting from 0 to 180, and set 3 starting from 10 and maximum being 80. Now the mean for all the sets is 50, but the variations are different. As we saw before, the variations were the range or the minimum and maximum values are the widest away from the mean are the maximum. So in the first set, which is 50 50 50, there is no variation. Large variations in the second, and some variations in the third. In order to measure dispersion or variation, different things like range, mean deviation and standard deviation are used. So these are terms, some of which we've just discussed and some which we'll discuss now. So what is a range? A range is essentially the difference between the highest and the lowest values. So for example, in this set, the range for the first observation would be difference between the highest and the lowest, 0. Good. For the second one, it will be 180 minus 0, so 180. And in the third one, it will be 80 minus 10, which is 70. So that is what range is. Mean deviation. Now this is different from standard deviation. This is mean deviation and is basically the sum of absolute deviations from the mean. And this is the formula. The two symbols here stand for absolute value, which is essentially if this value was minus 5, then if you put the absolute sign, this becomes equal to 5. The positive value in all case, an absolute of any number is always positive. So the mean deviation is the sum of absolute deviations of all the numbers in the set around the mean. So let us look at a quick example to consolidate our understanding of mean deviation. So for this data, 13, 8, 9, 12 and 9 again, find the mean deviation. The first step is to find the mean itself, and which is the number into the number of times that the number occurs. So 13 occurs once, so 13 into 1, plus 8 into 1, 8 occurs only once, plus 9 into 2. So you have a 9 here and a 9 here in the end, and then 12 into 1, so you get the mean as 10.2. Now mean deviation is the absolute difference between each number in the set and the mean. So there are total 5 numbers, and so taking the first one, it will be 13 minus 10.2, then 8 minus 10.2, and then 2 into 9 minus 10.2, and so on, and thus you get the mean deviation as 1.84. Okay, so that was all the theory that you need to know for statistics for your test, and let's go through a few solved examples to consolidate our understanding and revisit some of the concepts that we've discussed. So the first one, set A is 2, 5, 7, 9, 10, 13, 15. Set B is 14, 9, 4, 5, 12. What is the difference between the mean of B minus A and the median of A minus B? Now if you recall your set theory, then B minus A would simply be all the elements that are in B which are also in A. So looking at this quickly, what you find is 2 isn't in B, 5 is in B, so I'll take that out. 7 is not, 9 is, so I'll take this out. 10 is not, 13 and 15 are not. So essentially B minus A would be 14, 4 and 12. And similarly A minus B would be 14 is not in A, 9 is in A, so I take out 9. 4 is not in A, 5 is in A, so I take out 5, and 12 is not in A. So what I have remaining is 2, 7, 10, 13 and 15. So that is A minus B. Now for these two sets we need to find the difference between the mean of B minus A. So the mean for this and the median for this. Now to find the mean of these values, we need to arrange them in ascending order. So I have 4, 12 and 14, and by simple mathematics I get the mean as 10, which basically is equal to 12 plus 14 plus 4 divided by 3, which is 10. And let's look at the other set now. So median is the middle value, and you can clearly see it's already in ascending order, so the median is 10 as well. So the difference between 10 and 10 is 0, so the answer should be 0. Let's have a quick look at the formal explanation of the answer. So mean you get as 10, and the median you get as 10, and the difference is 0. The second example is about variation. So Larry, Steve and Bill hold 352, 198 and 275 shares in LPR. LPR is a company. LPR merges with LIR and the shares are swapped in a certain ratio. Find the variance of their holdings in LIR. So essentially we need to first find the new number of shares and then the variance of their holdings. So let's have a quick look at how to go about solving this. So this is the initial set of shares they had on the top, and then these were swapped in a 11:1 ratio, and this is the new set of numbers we need to work with. And the first thing we need to do is to find the mean. So to get the mean, you simply do add them and divide by 3, so the mean comes out to be 25. And using our variance formula, what we need to do is that for each of these, each of the set of shares that Larry, Steve and Bill hold, we need to find the difference from the mean and then square it. So taking the first one, Larry has 32 shares, the mean is 25, so it'll be 32 minus 25 square. Similarly, it'll be Steve's 18 minus 25 and then 25 minus 25 square. And simply putting the values in this formula, we get this, and this comes out to be 98.3. So a lot of stats questions are simply about knowing the right values to plug into a formula. You are very unlikely to get a question like this without also getting the formula. So especially in the data interpretation section, where there is a large table with multitude of data, you might get a question or two on variation or standard deviation, but you will also get this formula. It's useful to be familiar with the concept though, so that you know for sure that you are on the right track when solving the questions. So this is a conceptual question. The standard deviation of 10 items is 4. If each item is increased by 2, then the standard deviation increases by 2, decreases, increases by 4, remains unchanged, or we cannot determine since we do not know the original standard deviation. Now if you remember, standard deviation is essentially the concept of how much away from the mean are each value in the set. So if all the values of the set increase by 2, then the difference from the mean would be pretty much the same as it originally was. So conceptually looking at it, the standard deviation should really remain unchanged. But let's have a look at the solution, and then we can. So the answer is indeed D, which remains unchanged. And this is how you do it. So this is the standard deviation formula. The standard deviation is 4 initially, and if each item is increased by 2, then the mean is original mean plus 2. So the mean goes up by 2 as well, as you can see here. And the standard deviation for the new set which you get after adding 2 is given by this formula. And if we go to the next page, you will see that on reducing the formula, simplifying it, you get the same standard deviation as the old one. So you can work out the mechanics. Essentially what you're doing is replacing the mean value here by the new mean value to get this equation. So here is the last question on variation. The scores of 5 students in a test where the maximum marks are 50 are represented by this set. You have to find the variation. And later on, the maximum marks are increased to 100 from 50, and accordingly each student's score was doubled. Find the variance of the new scores. So let's see how we may solve this one, and these are the possible answers. So here we go. So this is a table that represents the scores. So essentially this is the student number, this is the actual score, this is the deviation from the mean of each one, and this is the square of that. So the total of all the scores is 180, and hence the mean is 180 divided by the total number of students, so 36. And the variance, which is the square of standard deviation, is given by the sum of these numbers, the square of the differences, and divided by the total number, so you get 43.2. Now when the scores are doubled, what we get is a similar table with slightly different figures. So this column represents the double scores, so the mean would double as well as expected, so the mean is 72, and the variance in this case is 172.8. So when the scores double, the variance becomes 4 times. Hence the answer is choice A. So here's a shortcut to how you might solve this without having the second table. So you know that each of the scores is doubled, which means the mean is also doubled. Then in the first case, if y equal to xi minus the mean, then we have this equation, and from the calculation of variance we have and hence the variance is quadrupled. Now if you don't understand this fully, I request you to rewind and take another look at the formulae, and it'll become clear that if all the values of a set double, then the variance becomes 4 times. So hope you enjoyed this session. Thank you very much and look forward to seeing you again.